April 26, 1943. Outside the small French coastal town of Brest, morning fog clings to crumbling medieval walls. In a muddy field, 3 kilometers from the Luftwaffe airfield, a crowd has gathered. Not farmers, not villagers, uniformed men, dozens of them, their breath condensing in the cold Atlantic air. They stand in a perfect semicircle, as if before an altar, and in a way they are. Before them rests a creature that was never meant to touch Earth so gently. Its 4 propellers are bent like broken fingers. Its wings, spanning 31.5 meters, are perforated with hundreds of jagged holes. The nose section, normally a clear plexiglass dome for the bombardier, is shattered, revealing a chaotic tangle of wires and instruments within. This is a Boeing B-17 Flying Fortress, serial number 41, 24, 581. To its American crew, it was flak magnet. To the men staring at it now, it is something else entirely, an enigma, a warning, a window into an industrial future they cannot comprehend. The senior engineer from the Luftwaffe's Rechlin test facility pushes his wire-rimmed glasses up his nose. His hands, usually steady when drafting blueprints or calculating stress loads, are trembling, not from cold, from mathematics. The numbers are already forming in his mind and they make no sense. Beside him, a test pilot with Jagerschwader 2, who has flown against these bombers since 1942, spits into the mud. His face is pale. This pilot has watched fortresses absorb punishment that would tear a Messerschmitt Bf 109 inches half. He has seen them lumber home on 2 engines, their aluminum skin peeled away like tin from a can, their crews still alive. But standing next to one, touching its skin, examining its construction with his own hands, this is something different. This is intimacy with the enemy, and intimacy, he is beginning to understand, breeds not contempt but terror. The aircraft before them did not fall to German guns. Not directly. It had completed its mission, bombing the submarine pens at Lorient, when a flak burst severed its fuel lines. The pilot, Lieutenant Charles Brown, had nursed it across 200 kilometers of occupied France, losing altitude with every minute. When he finally set it down in this field, the fortress slid 300 meters through mud and rock, shedding parts like a wounded animal shedding blood. The crew was captured immediately. The aircraft, remarkably, remained mostly intact enough to fly again. And that is why the evaluation team is here. Their orders, signed by General Feldmarschall Milch himself, are simple. Verstehen Sie es. Understand it. Dissect it. Learn every secret, every weakness, every reason why this machine is breaking the Luftwaffe's back over the Reich. The senior engineer walks to the starboard wing. He runs his fingers along the leading edge, feeling the rivets. There are thousands of them, perfectly spaced, uniformly set. He pulls a micrometer from his leather satchel and measures the skin thickness, 0.8 millimeters, 2 millimeters thick near the engine nacelles. He knows already that German aircraft use similar gauges, but something about this aluminum feels different. He will later discover it is not the metal itself, but what has been done to it. Alclad treatment, a process of bonding pure aluminum to stronger duralumin alloy, creating a surface that resists corrosion without sacrificing strength. The Germans have this technology. The Americans have turned it into poetry at industrial scale. A truck arrives. Ground crew begin winching the bomber onto a flatbed. The engineer watches as the enormous weight, 32,000 pounds of empty airframe, groans onto the trailer. The truck will take it to Brest Harbour. From there, a cargo ship, escorted by 2 destroyers, will ferry it across the mine-infested waters of the Bay of Biscay. Destination: Rechlin, Lairs, north of Berlin. There, in a hangar with blackout curtains and armed guards, the true examination will begin. The engineer already knows what his report will say. He can feel it forming in his chest like a stone. This is not just an aircraft, it is a question. And the question is, how can any nation build so many of something so complex? May 3rd, 1943, Rechlin-Lairs Airfield. The hangar is climate-controlled, which is unusual for a military facility in wartime. Humidity, the evaluation team knows, is the enemy of precise measurement. Around the B-17, now supported by a complex scaffold of German engineering, technicians move like ants around a fallen beetle. Cameras on tripods document every angle. Draftsmen, their pencils whispering across vellum, sketch components that will fill 247 technical drawings. This is not mere curiosity. This is an autopsy performed by a nation that is losing the air war. Every finding will be rushed to the Focke-Wulf plants, to Messerschmitt, to Heinkel. Every flaw will be exploited. Every strength will be countered. Or so they hope. The team begins with the structure. The B-17's fuselage is not a monocoque, not a single, stressed shell, like the Focke-Wulf 190. It is a frame and stringer construction, covered in aluminum skin. To a German engineer raised on the elegance of single-shell design, this seems primitive, wasteful, heavy. They calculate the weight penalty, at least 15% heavier than necessary, a flaw, a genuine flaw. But as they remove the interior panels, their initial assessment crumbles. The frame is not one continuous assembly. It is modular. 5 major sections: nose, forward fuselage, center section, aft fuselage, tail. Each can be manufactured separately. Each can be transported by rail. Each can be assembled in a final plant by semi-skilled labor. The team sees the rivet patterns change at section joints. Quick-release fasteners, quarter-turned Zeus fittings. The entire electrical system, they discover, is bundled into loomed harnesses that clip in like German children's toys. A technician with 6 months training can install an entire fuselage wiring system in 4 hours. In Germany, master electricians spend 3 days threading individual wires through the fuselage of a Heinkel 111. The word begins to form in their reports, a word they have only read in American industrial journals. Asterisk modularization. Asterisk. They move to the defensive armament. The B-17 Farads carries 13 50 caliber Browning M2 machine guns, 7,700 rounds of ammunition. Total weight of the defensive system, 2,400 pounds. The test technicians have reassembled one of the Brownings on a test stand. They have been firing it for 3 days, measuring rate of fire, accuracy, reliability. The numbers are revoltingly consistent: 750 rounds per minute, effective range 1,000 meters, and the guns are identical, all 13. Same part number, same breech mechanism, same feed system. They examine small metal parts, extractors, firing pins, springs. The armaments specialist reports, "These components are interchangeable. I have taken bolts from 7 different guns. They fit perfectly in all receivers. The tolerances they are not German tolerances. They are something else. They are forgiving. Forgiving." The word hangs in the hangar air. German engineering is not forgiving. It is precise, demanding. A Focke-Wulf 190's MG 151 cannon requires hand-fitting by armourers. Each weapon is married to its mount, its ammunition feed, its firing solenoid. If one fails in the field, you cannot rob parts from another. You must wait for factory-fitted spares. But this American gun, this Browning, it is a commodity. Like nails, like bricks. It is a product of a system that values function over perfection. The stone in the team's collective chest grows heavier. The electrical system receives its own dedicated team. The B-17 has 2 separate 24-volt direct current systems, redundant generators, redundant batteries. But it is not the redundancy that shocks the German engineers. It is the standardization. Every wire is color-coded. Every circuit breaker is labeled in English and a numerical code. The entire avionics package, radio, navigation equipment, gun sight heaters, bomb release circuits, plugs into a central bus bar. The Norden bomb sight, which they have recovered intact, connects via a single multi-pin connector. In Germany, the Lotfe bomb sight requires 2 technicians and 3 hours to calibrate and install. The Americans can swap a Norden in 20 minutes. The implications are beginning to crystallize in their reports. Maintenance. That is the true secret of the fortress. Not its speed 290 miles per hour, barely faster than a loaded Junkers Ju-52 transport. Not its bomb load 4,000 pounds at long range, less than a British Lancaster's 7,000. The secret is that for every hour it flies, it requires only 20 minutes of maintenance. A German bomber needs 3 hours. Simple arithmetic. Fly 8 hours, maintain for 24. The bomber is grounded 3/4 of its life. But a fortress? Fly 8 hours, maintain for 2 hours and 40 minutes. It is airborne 70% of the time. They do the calculation for the 100th time, hoping for a different result. It never changes. To match one American bomb group flying 100 B-17 seconds, Germany would need to produce and maintain 420 traditional bombers. They are not producing 420 of anything. Not anymore. June 7th, 1943. The complete report sits on the desk of General Feldmarschall Erhard Milch, State Secretary for Aviation Production. Milch reads it in one sitting, his face growing increasingly ashen. When he finishes, he pours a glass of schnapps and stares out his Berlin office window at the smoke from the previous night's RAF raid. He summons his production chief, Dr. Wilhelm Zorn. Zorn, read this, then tell me how many bombers we built last month. 241, Herr Feldmarschall, including conversions. And the Americans? We estimate 400, perhaps 420. Milch slams the report onto the desk. The glass in his hand trembles. No, Zorn, not 400. Not 420. Read what the evaluation team says about the Boeing plant in Seattle. Seattle, the Boeing plant 2, not the mythical Ford Willow Run that would later build B-24 Liberators. Boeing had transformed its facility into a continuous flow of aluminum. 25,000 workers, many drawn from the automotive industry, now worked in 8-hour shifts. Each worker performed a single task, rivet number 7412, hydraulic line 3 beta. Training time, 6 weeks. In Germany, aircraft apprenticeship takes 3 years minimum. Milch's mind reels. He understands production. He has overseen the construction of synthetic fuel plants, the underground factories for jet engines. But this is not production. This is alchemy. Mass production of complex machinery at a scale that defies military logic. The report continues. The Boeing plant employs thousands of workers, but here is the crucial detail. Only 11% are skilled aircraft mechanics. The rest are drawn from the automotive industry, welders who made car frames, electricians who wired commercial vehicles, assembly workers who installed fenders and engines. Boeing has not created a new army of aircraft specialists. It has adapted an existing army of industrial workers to a new product. Milch's schnapps is gone. He pours another. The Americans have been at war for 18 months. Total. How many B-17 seconds have they built? The intelligence says, perhaps 3,000. Open the annex. Appendix 7. Projected production curves. Zorn flips to the back of the report. The graph is simple. The x-axis is time, from December 7th, 1941 to December 31st, 1944. The y-axis is cumulative B-17 production. The curve is not linear, it is exponential. It starts shallow, then becomes impossibly steep. At the end of the line, a number, 12,731. Zorn's lips move silently as he reads the words. But this is impossible. 12,000? No, Zorn, it is not impossible. It is arithmetic. They have already built 4,000. The Boeing plants alone will build 6,000 more before the war ends. One factory network. One network will produce more heavy bombers than the entire German aircraft industry combined. And this is not our worst problem. Milch walks to a map on the wall. It shows the German aircraft production network, factories in Bavaria, in Saxony, in the occupied territories, each marked with a red pin. Our factories are in cities. They are above ground. They are vulnerable to the very bombers this report analyzes. The Americans build in Seattle, in Wichita, in Marietta. No German bomb has ever fallen on Seattle. No German bomb ever will. They build in safety. They build in numbers. They build. He pauses, searching for the word that has haunted him for 3 days. Forgivingly, July 15th, 1943. Back at Rechlin, the evaluation team has identified 16 specific vulnerabilities in the B-17's design. They have test-fired guns at captured sections. They have flown a rebuilt fortress against German fighters. They have created a manual, now distributed to every Jagdgeschwader in the West. Asterisk. Amerikanische Schwachstellen. B-17 Flying Fortress. Asterisk. The manual is 70 pages long. It is brutally specific. Page 12. The nose compartment is a kill zone. The bombardier and navigator sit behind minimal armor. A 30mm cannon shell through the plexiglass will kill both crewmen and destroy the Norden bomb site. Page 18. The number 2 engine, the inboard starboard, sits directly above the main fuel line from the wing tanks. A single incendiary round can sever the line, dumping fuel onto the hot engine. Page 23. The ball turret, while providing excellent coverage below, has a blind spot directly beneath the tail. Attack from below, breaking away at the last moment, and the tail gunner cannot respond until you are already out of range. The manual works. In August of 1943, Luftwaffe pilots using these tactics destroy 60 B-17 seconds in a single week. The air over Schweinfurt becomes known as Black Thursday. American bomber losses reach 16% per mission. The United States Army Air Force is forced to suspend deep penetration raids into Germany. Goering crows victory. Milch allows himself a rare smile. The evaluation team receives commendations. The flaws are real. They are exploitable. They are killing Americans. But there is a problem. A problem that gnaws at the engineers as they read the combat reports. Yes, they are destroying B-17 seconds. But they are not destroying the B-17. The concept, the system. For every fortress that falls, 3 more arrive to replace it. The manual, for all its technical brilliance, is a document written by engineers who understand machines but do not understand production. It treats each bomber as a precious artifact, as a carefully crafted machine whose loss matters. But the Americans are not craftsmen. They are manufacturers. They do not grieve the loss of 1 bomber. They amortize it across a production run of 12,000. The team sees the error in their own thinking on a hot afternoon in late July. They are in the hangar, watching a group of mechanics struggle to repair the hydraulic system of a captured B-24 Liberator. The parts do not fit. They have been cannibalized from 3 different aircraft. The German mechanics curse and file and shim. It takes them 18 hours to complete a task, the manual says, should take 4. They realize the manuals are wrong, not factually, but philosophically. They assume German conditions, German supply chains, German precision. The B-17 is not over-engineered. It is differently engineered. It is engineered for maintainability, for replaceability, for forgiveness. The tolerant stack-ups that they measured and found wanting, they are deliberate. They allow a ball turret gunner, freezing at 20,000 feet, to replace a damaged feed chute using a single screwdriver and a hammer. The electrical harnesses that seem crude, they are color-coded for a 17-year-old farm boy from Iowa who 6 months ago was repairing tractors. The modular sections, they allow forward repair depots in England to swap an entire nose assembly in 6 hours, returning a damaged bomber to flight, while the original nose section goes back to a rear depot for complete rebuild. The team adds a final page to their report. It will never be read by the pilots who need it most. It is too late. The war has moved beyond tactics. It has become a contest of throughput, of industrial metabolism, and Germany's metabolism is failing. September 1st, 1943. A second B-17G arrives at Rechlin. This one was forced to land in Denmark after an engine fire. It is almost pristine. The evaluation team begins their analysis again, but this time with different eyes. They are no longer looking for flaws. They are looking for secrets they have missed. The defensive fire control system. They missed this. While the B-17G's chin turret provides improved forward defense, they discover the real advantage. Each gun position uses standardized Sperry or Emerson mechanical sights. Not centralized control, but distributed simplicity. Each gunner can effectively track targets without complex training. The Germans have nothing like it in their bombers. Their heavy fighters, the Me-410 and the Ju-88, rely on fixed forward-firing guns. The concept of flexible, individually aimed defensive arrays is alien. They could have built it. The technology is not new, but they did not think to apply it this way. They were too focused on offensive firepower, too confident in the attack. The turbo superchargers. They missed this too. General Electric B-series turbos, mounted on each right Cyclone radial engine, maintain power at 25,000 feet. German engineers have examined this technology before, in captured P-47 Thunderbolts. They know it works, but they have not implemented it widely. The German High Command believes the air war will be fought at medium altitude, 10 to 15,000 feet, where the existing mechanically supercharged DB-601 engines are adequate. The Americans have made a different bet. They have built an entire bomber fleet to operate above the effective ceiling of German flak and most German fighters. It is a strategic choice expressed in hardware, and it is the correct choice. The oxygen system. This they completely misunderstood. The B-17 uses a central liquid oxygen converter, feeding a network of individual regulators at each crew station. The system is automatic. A crewman plugs in, and the system delivers the correct oxygen mixture based on altitude. German aircraft use chemical oxygen candles, or individual bottles. The candles are unreliable, the bottles are heavy and must be manually changed. American crews can operate at high altitude for 6 hours without touching their oxygen equipment. German crews must monitor and adjust constantly. Another small detail. Another accumulated disadvantage. End. Fur. In a 6-hour mission, a German crew makes 200 manual adjustments to life support. An American crew makes none. The cognitive load difference is measurable. It is the difference between a crew that is exhausted and one that is merely tired. But the most profound missed opportunity is not a technology. It is a philosophy. The B-17 cockpit features a control yoke, not a stick. The instruments are arranged in a standardized pattern, identical in every bomber the USAAF fields. A pilot checked out in a B-17 can fly any B-17. But a German pilot trained in a Ju-88 cannot transition to a Heinkel 111 without extensive retraining. The instrument layouts are different. The control responses are different. The emergency procedures are different. The Americans have created a platform. The Germans have created a collection of types. When the Americans replace a pilot, the new man needs only to learn the mission. When the Germans replace a pilot, the new man must first learn the aircraft. In a war of attrition, this difference is fatal. The evaluation team compiles a second report. This one is not for Goering or Milch. It is for the designers, for Heinkel and Messerschmitt and Focke-Wulf. They title it simply, Asterisk, was wir nicht gesehen haben. Asterisk, what we did not see. They know it is academic. The designers are brilliant men, but they are trapped in a system that rewards bespoke solutions. The RLM, the Reich Air Ministry, issues specifications for aircraft that are masterpieces of precision. Each new type is expected to be superior to its predecessor in every metric. The American system, they now understand, does not demand perfection, it demands adequacy. At scale. The B-17 is not the best possible heavy bomber. It is the best heavy bomber that can be built by 25,000 workers in a continuous production flow. That is a different definition of best. And it is winning the war. November 18th, 1943. The Schweinfurt raids resume. The Americans have not solved the defensive problem. They still lack long-range fighter escort. The Luftwaffe, using the evaluation manual, is destroying bombers at a rate that would have been unsustainable a year ago. 6 bombers lost today, 7 tomorrow. 12 on a bad day. The American 8th Air Force should be bleeding to death. Instead, it is growing. The number of bombers per raid increases from 100 to 200, from 200 to 300. The losses remain 16%, but 16% of a larger number is an absolute loss the Americans can absorb. And absorb it, they do. For every fortress that falls over Germany, 3 more arrive from Seattle, from Wichita, from Marietta. The pipeline is endless. In Berlin, Milch convenes a meeting of the fighter staff, the most important production conference of the war. Speer is there. Goering is there, though he says little, his morphine haze settling into permanent detachment. The topic is simple. Can Germany produce enough fighters to stop the bombers? The numbers are placed on the table. Current fighter production, 1,080, me 109 seconds per month. Required fighter production to achieve air superiority over the Reich, 3,000 per month. Current fuel allocation for training new pilots, 30,000 tons per month. Required fuel to sustain 3,000 fighters, 120,000 tons per month. The synthetic fuel plants, the very targets the Americans are bombing, are producing at 80% capacity, declining. The mathematics are inexorable. Speer, the architect turned armaments minister, is a man who understands numbers. He has built his reputation on increasing production despite the bombing. He has dispersed factories underground. He has rationalized supply chains. He has achieved miracles. But he looks at Milch's report on the B-17 and sees something different. He sees not a production problem, but a civilizational problem. Gentlemen, we are not fighting a military force. We are fighting a production function. The Americans have taken the principles of the assembly line and applied them to the most complex machine ever mass-produced. We are still building aircraft the way we built cathedrals, with craftsmen, with masters and apprentices. This is not a question of will, it is a question of industrial DNA. The room is silent. Goering stirs, his eyes focusing briefly. I have seen these bombers. I have seen them over Berlin. They are not invincible. My pilots bring them down. Yes, Herr Reichsmarschall, your pilots bring them down. But the Americans build them faster than we can shoot them down. It is a race we cannot win. They are building a flying door. We are building a flying vault. The door is good enough. The door is cheap. The door can be replaced. The vault is perfect. The vault is expensive. The vault, when it is destroyed, is gone forever. The metaphor hangs in the room like a bomb that has not yet detonated. A flying door. Good enough. Replaceable. The opposite of German engineering philosophy. The opposite of the Teutonic myth of quality. Speer continues. We have examined their workers. They are not better than ours. They are not more motivated, but they are organized differently. A German worker spends 8 hours building a fuselage frame. He is responsible for the entire assembly. He is a craftsman. An American worker spends 8 hours riveting panel 741 to frame member 203. He does not know what the final product looks like. He does not need to know. He is a component in a larger machine. The machine builds the bomber. The bomber is a product of the machine, not of the man. Milch looks at the graph again. The exponential curve. The 12,731. He makes a decision. A desperate one. We must build our own fortress, not a copy, but the German equivalent. A bomber that is adequate, not perfect. A bomber that can be built by auto workers. We have the Opel plants. We have the Volkswagen works. We will create a simplified bomber. The project is codenamed times WESP asterisk, the Wasp. It will be a twin-engine bomber using existing Junkers engines. It will have a wooden fuselage to conserve aluminum. It will have a simple, fixed defensive armament. It will be designed not by aircraft engineers but by automotive production engineers. Speer approves the program. 1 billion Reichsmarks. Completion target. March 1945. At Rechlin, the evaluation team hears about times, Wesper times, and understands its futility. They have seen the American system from the inside. It is not a bomber that is simple. It is the entire ecosystem. The tooling, the supply chain, the worker training, The maintenance doctrine. You cannot graft simplicity onto a craftsman culture. It is like asking a watchmaker to build a tractor. He might succeed, but it will take 10 times as long and cost 100 times as much, and it will still tell time. Vesper Times will produce 3 prototypes. They will fly in February 1945. One will crash on its 3rd flight due to a wooden structural failure. The other 2 will be captured by advancing Soviet forces, who will dismiss them as curiosities. The program will be remembered only as a footnote in a report on Germany's failure to adapt to total industrial war. February 4th, 1944. The evaluation team is back in the hangar. The original B-17, flak magnet, has been joined by 3 others. One is completely disassembled, its parts laid out in rows like a dinosaur skeleton in a museum. Another has been reassembled and is being used for flight testing. The third is a burnt hulk, recovered from a crash site near Hamburg. The engineers spend their days walking among them, pathologists who have forgotten which patient is which. They think about the workers who built these machines. They have seen the reconnaissance photos, the factory floors, the women in overalls, their hair tied up in bandanas, operating rivet guns. The men, many too old for military service, moving down the line with clipboards. The assembly line moves continuously. The workers do not stop. The bombers do not stop. It is a river of aluminum and steel, a river that flows from the American heartland to the skies over Berlin. They think about their own workers. The men and women, many of them forced labor from Poland and France, who build the Focke-Wulf 190. They work in caves now, in the Harz Mountains, by candlelight. They have no rivet guns. They have hammers and hand drills. They have blueprints that change weekly as the designers try to shave weight, add armor, improve the guns. Each FW-190 is unique, a snowflake of engineering, a masterpiece, and each takes 6,000 man-hours to complete. A B-17 takes 18,000 man-hours, but those hours are spread across 25,000 workers. The FW-190's hours are concentrated in the hands of 3,000. The mathematics are simple. The Americans build 1 bomber per day at peak production. The Germans build 1 fighter every 6 hours. The ratio is not sustainable. An intercepted American radio message circulates. Asterisk. For every bomber we lose, Boeing sends us 2 more. Gentlemen, we can afford to be brave. Asterisk. The engineers look at the disassembled fortress, at the perfect, modular, replaceable parts, at the simple, forgiving, adequate design. One turns to another and says, "We document, we analyze, we report, we do what engineers do, we measure the world, even if the world is ending." He walks to the chalkboard. He writes 3 numbers. 1 per day. 12,731. 750. The production rate. The total production. The rounds per minute of the Browning guns. These numbers are not just numbers, they are a statement of national will. They are... He stops. The chalk breaks in his fingers. They are the reason we will lose. April 7th, 1944. The 8th Air Force launches 1,000 bombers against German aircraft factories. Among them, 627 B-17 seconds. The raid is a disaster for the Luftwaffe, not because of the bombs dropped, but because of the message sent. 1,000 bombers. In a single raid. The entire German single-engine fighter force for the Western Front is 500 aircraft. The Americans have brought twice that number as escort fighters alone. An engineer at Rechlin is in his office when the sirens sound. The Americans have never bombed Rechlin before. It is too far east. But the war is coming closer. He hears the drone of engines. Thousands of them. The sound is not the high-pitched scream of German fighters. It is the low, relentless thrum of radials, of fortresses. He does not go to the shelter. He walks to the hangar, to the captured B-17, now fully reassembled and painted in German markings. He climbs into the cockpit. He sits in the pilot's seat. He grips the control yoke. It is not as precise as a German stick. It feels loose, forgiving. He hears the bombs falling in the distance. The hangar doors rattle. He thinks about the men who built this seat, the woman who riveted it into place, the man who bolted the control column to the floor. He thinks about the supply chain that brought the aluminum from the smelter in Alcoa, Tennessee, to the rolling mill in Detroit, to the stamping press in Seattle. He thinks about the railroads that moved the components, the ships that carried the finished bombers across the Atlantic, the training bases in Texas where farm boys learned to fly, the airfields in England where ground crews waited with pre-positioned spare parts. The entire ecosystem, humming like a machine, producing, deploying, maintaining, replacing. He sees it now. The B-17 is not a bomber, it is a node in a network, and the network is the weapon. The ground shakes. Flak batteries around the airfield open fire. The sound is impossibly loud. He remains in the cockpit. He is safe here, inside the American machine, inside the enemy's thinking. He thinks about the word that has circulated through the technical reports. Asterisk, forgiving. Asterisk. This bomber forgives its pilots their mistakes. It forgives the ground crews their inexperience. It forgives the supply chain its imprecision. It is a machine built for humans, not a machine built for engineers. And that, he finally understands, is why it is unbeatable. Outside, a bomb falls on the hangar next door. The concussion wave lifts the B 17 inches off its blocks, then sets it down again. The fortress shudders but holds. He laughs. Of course, the over-engineered frame, the primitive stringers, the excessive rivets, they were not a mistake, they were insurance. The Americans built a bomber that could survive its own destruction, a bomber that could be blown up and still be rebuilt, a bomber that could lose an engine, a wing, a tail, and still fly home, not because it was perfect, but because it was tough, because it was in the final analysis forgiving. The raid ends. Rechlin is cratered but functional. The B-17 inches the hangar is untouched. He climbs out of the cockpit. He is a man of the old world, a master of German engineering. He will live through the war. He will be taken prisoner by the Americans, interrogated by their technical intelligence officers, shown the ruins of German industry. He will eventually write a book, published in 1957, called Times Der Kreislauf des Krieges, * The Cycle of War. In it, he will describe the B-17 as the ultimate expression of American pragmatism. He will write, *, we built cathedrals, they built doors. The cathedrals were beautiful, the doors were everywhere. In war, quantity has a quality all its own. * January 1st, 1945. The final year. The numbers no longer need to be estimated. They are facts, carved into the ledger of war. The United States has produced 12,731 B-17 flying fortresses. Of these, 4,735 have been lost in combat. Another 2,000 have been lost in accidents. The loss rate is 53%, catastrophic by any standard. But the Americans have built replacements. They have built more than replacements. They have built an entire air force, sent it to war, lost half of it, and still have more bombers at the end than they started with. This is the arithmetic Goering never understood. This is the arithmetic that defeats Germany. In the final accounting, the B-17 drops 641,000 tons of bombs on Europe. It flies 291,000 sorties. It loses 35,000 crewmen, but it creates a fact on the ground. The fact is this: no German factory is safe, no German city is safe, no German worker can sleep at night without hearing the drone. The bomber is not just a weapon, it is a psychological instrument. It is proof that the enemy can reach you, no matter how deep you build your factories, no matter how many fighters you scramble. The bomber is a promise kept. The promise is, we have more. The German aircraft industry, in contrast, produces 2,850 heavy bombers during the entire war. Most of these are Heinkel 111 seconds, a design that first flew in 1935, obsolete by 1939. The few Heinkel 177 seconds, the German B-17, are built in numbers so small 849 that they have no strategic impact. They are beautiful aircraft, faster than the Fortress, heavier bomb load, better defensive armament, but they are cathedrals. Each one takes 20,000 man-hours. They are not replaceable. They are not forgiving. When they are destroyed, they are gone. The Messerschmitt Me 264. Germany's attempt at a truly strategic bomber never flies operationally. The prototypes are beautiful, all smooth curves and advanced engines, but they require materials Germany does not have. They require factories that have been bombed. They require fuel that is being synthesized from coal at ruinous cost. The program is cancelled in 1944, not because the aircraft is bad, but because Germany cannot afford to build a bomber that is merely adequate. It can only afford to build fighters, defensive weapons, the tools of a nation that has lost the initiative. And still the B-17 seconds come. In January of 45, they will bomb Dresden. In February, they will support the crossing of the Rhine. In March, they will drop food to the starving Dutch. In April, they will fly their last missions, their bomb bays empty, their crews waving at the Soviet soldiers they see below, the war already won. The bombers that survive will be flown back to the United States. Many will be sold for scrap, their aluminum melted down to make refrigerators and cars. The Boeing B-17 will become the DC-3 of the military world, ubiquitous, unremarkable, a tool that did its job and was put away. May 8, 1945. V-Day. In a prisoner of war camp near Munich, a former engineer from the Rechlin evaluation team listens to a hidden radio. The announcer, in English, describes the victory parade in New York. The man thinks about the word he has carried since that first day in the field outside Brest. Asterisk forgiving. Asterisk. The Americans built a bomber that forgave its crew's mistakes. That forgave the ground crews their inexperience. That forgave the supply chain its chaos. That forgave the war itself its brutality. The B-17 was not a cathedral, it was a door that opened into the modern world. A world where complexity is managed by modularity, where quality is defined by replaceability, where the craftsman yields to the technician. He will return to Bavaria. He will rebuild his life. He will teach at a technical college. He will never design another aircraft. In his lectures, he will show his students a single rivet from the B-17. He will pass it around the classroom. He will tell them to feel its weight, its uniformity. He will say, asterisk, this rivet was made by a machine, set by a worker who did not know my name. It holds together a bomber that helped destroy our nation, and yet it is not evil. It is merely a rivet, a component, a part of a system that was so large, so forgiving, that it could absorb the loss of 12,000 of itself and still have more. In the end, we did not lose to a weapon. We lost to a method. We lost to a door. Asterisk. December 7th, 2023. The National Museum of the United States Air Force, Dayton, Ohio. In a quiet corner of the World War II gallery, a B-17G sits on display. Its name is Time's Shoo Shoo Baby. Asterisk. It flew 24 missions. It was shot down over France in 1944. It was rebuilt, like a phoenix, from the parts of 3 other bombers. It is a mongrel, a survivor, a testament. Visitors walk past. They see a big, ungainly aircraft. They see the chin turret, the ball turret, the tail guns. They see the faded paintings of bombs on the side, each one a mission. They see the patched bullet holes. They see the cathedral. But if you know what to look for, you see the door, you see the rivets, uniform as a ruler's edge. You see the modular panels, the quarter-turn fasteners. You see the production plate, stamped with a date and a plant number. You see the invisible river of aluminum that flowed from the factories to the sky. You see the 25,000 workers, the 6-week training, the daily production rhythm. You see the mathematics, the forgiving mathematics, and you understand. The B-17 was not just a bomber. It was a message. A message written in the language of mass production. The message was, we can build more. We can always build more. Your perfection cannot match our adequacy. Your cathedrals cannot withstand our doors. We will lose some, we will lose many, but there will always be more. and in the end, more is what wins. The last B-17 rolls off the assembly line in July 1945. It is named Time's The Last One. Asterisk. It is never used in combat. It is flown directly to a storage depot in Arizona, where it will sit for 20 years before being sold to a firefighting company. It will spend its retirement dropping water on forest fires. Even in peace, it is useful. Even in peace, it is forgiving. The Germans built 2,850 heavy bombers during the war. The Americans built 12,731 B-17 seconds, plus 18,000 B-24 seconds, plus 10,000 B-25 seconds, plus 15,000 B-26 seconds. The total is staggering. The total is victory. In the end, the German engineers did understand the B-17. They understood every rivet, every wire, every flaw. What they could not understand, what they could not measure or diagram or exploit, was the system that built it, the system that forgave its flaws, the system that replaced its losses, the system that won the war not through brilliance, but through persistence, through the simple, relentless, adequate production of a machine that was good enough. The B-17 was not a miracle. It was a method, and the method was mercy. Mercy for the crew, who could survive mistakes. Mercy for the ground crew, who could fix it quickly. Mercy for the nation, which could afford to send it into danger because it could always build another. In a war of industrial extermination, the most forgiving machine wins. The river of aluminum never stopped flowing. It flows still, in different forms, in different factories, in different nations. But the lesson remains. When the engineers examined the captured fortress, they saw a bomber. They should have seen a door. When they measured the rivets, they saw tolerances. They should have seen mercy. When they counted the production numbers, they saw mathematics. They should have seen the future. The future belongs to those who build doors, not cathedrals. The future belongs to those who forgive, not those who perfect. The B-17 taught a lesson the Germans could not learn in time. It is a lesson the world is still learning. In the age of mass production, in the age of disposable technology, in the age of the replaceable and the adequate, the fortress still flies. Not in the sky, but in the method, in the mercy of the machine. And somewhere, in a museum, a rivet waits. It holds together the memory of a war. It holds together the proof that sometimes the simplest answer is the most powerful, the most forgiving, the most final.